So in this video, we're going to be going over linear equations. And the simplest linear equation that we know about is the equation y is equal to x. Now, if y is equal to x, what that means is that for any value of x, y has the exact same value as x. So if x is equals to 0, y is also equal to 0. When x is 1, y is 1, x is 2, y is 2, and so on. And if I was to plot a graph for this equation y is equal to x, if I plot a graph, so let's look at a graph over here. If I plot a graph, I realize that this graph passes through the origin, right? So when x is 0, y is 0. This graph passes through the origin. When x is 1, y is 1, x is 2, y is 2, and so on. And same for the negative values over here. So I draw these points, and once I plot a graph of this is what the graph will look like. It's a straight line that's passing through all of these points. So this is the graph for y is equal to x. Now, let's think for a moment what would happen, or how the graph for the equation y is equals to 2x would look different. So when I have the equation y is equal to 2x, this is also a linear equation. But now, what this equation is telling me is that for any value of x, y is equal to twice that value. So if I look at a table again, if x is equal to 0, then y is equals to 2 times 0. So that point remains the same. But now when x is 1, y is 2. When x is 2, y is 4, 6, and 8. When x is minus 1, y is minus 2, and minus 4, minus 6, minus 8. And if I draw a graph of this, so let's plot these 3 points over here, and then the 3 points on the negative side. And I realize that this graph actually turns out to be a lot steeper. So this graph is twice as steep. So what did we do here? What did we change? Well, we multiplied x by this factor 2. And this factor over here is called the slope, also denoted by the letter m. So the greater the slope of the graph, the steeper the graph becomes. Now what exactly is the slope? Well, the slope is, how we define it, is basically the change in y over the change in x. Now what do I mean by that? If I look at the first example for y is equals to x, I realize that if I change x by a value of 1, y changes by 1. For example, from here, from minus 2 to 2, if I change x by a value of 4, y is also changing by a value of 1, 2, 3, and 4. So y is also changing by 4.
Quick pause. If you're finding value in this explanation, there's so much more to discover. At Alt Academy, we break down every A-level concept with the same level of clarity. Now, let's continue.
So the slope over here is simply the change in y. We use the symbol delta to denote change. The slope is simply the change in y over the change in x. So for the first example, the slope is simply equals to 1. Whereas for the second example, the slope is equals to 2. What does that mean? Well, if I change x by a value of 2 from 0 to 2, let's say, then y will change by a value of 4. So if I look at the blue graph, if I change x by 2, y changes by 4. If I change, let's say, x from minus 1 to 2, if I change x by 3, then y will change from minus 2 to plus 4. So y is changing by plus 6. Similarly, if I change x by, let's say, minus 2, then y will change by minus 4. So the change is always the change in y over the change in x is a constant, which is equals to 2. So for linear equations, the slope is a constant. It's simply defined as the change in y over the change in x, and is a constant. Now if I look at a third example, in the third example, let's look at the graph for y is equals to minus 2x. Now over here, for example, if I look at the graph for y is equals to minus 2x, when x is 0, again, y is 0. So this graph is also passing through the origin. When x is 1, when x is increasing by 1, y decreases by minus 2. Increases by another 1, y decreases by a further amount of minus 2. And so on. Minus 6, minus 8, and then 2, 4, 6, 8. And if I plot this graph, this is what the plot looks like. So the slope over here the slope over here is the change in y over the change in x. And it is a negative slope. So, in a negative slope, what happens is, so if I compare the slope over here, the slope over here is m is equals to minus 2. So for the first two equations, as I move from left to right, as x increases, y also increases. So if I go from left to right, the graph moves upwards. Similarly, if I go from right to left, if x decreases, y also decreases. For a negative slope, if I go from left to right, as x increases, y is decreasing. And if I go from right to left, as x decreases, y is increasing. And the magnitude of the slope, so over here, for example, the magnitude of the slope is 2, whereas over here is just 1. The greater the magnitude of the slope, the steeper the graph. So y is equals to 2x is twice as steep as y is equals to x. Similarly, the magnitude of the slope for y is equals to minus 2x is also 2. But because it's a negative slope, it's moving in the opposite direction. If this slope, so y is equals to minus 2x, for example, would be steeper than the graph for example, something like y is equal to minus x. For y is equal to minus x, the graph is as steep as the graph y is equal to x. But as I go from left to right, for y equals minus x, the graph will decrease. So the steeper the slope, the greater its magnitude. So if, for example, y equal minus 2x or y is equal to 2x, the magnitude of the slope is simply 2, whereas for y equal x, the magnitude of the slope is 1. The greater the magnitude of the slope, the steeper the graph. A positive slope means that as I go from left to right, the graph increases. So if x increases, the y also increases. Whereas if it's a negative slope, if I move from left to right, then the graph decreases. In other words, as x increases, y decreases.
Now that that's taken care of, head over to our website to watch the rest of our A-Levels maths course. With 60,000 students trusting us, visit Alt Academy now and transform your A-Levels journey.